And we are live.
Okay.
Hey guys, if you can hear us, please say yes in the chat. Hello everybody, if you can hear us, please say yes. Alright, that's a go.
Hello and welcome to the first ever live stream on YouTube by Young Scientist. My name is Atreya and I have a special guest here, Satish, who has been the facilitator for the workshop series titled YS Space Missions. Could you tell us more about it, Satish?
Oh, I will. I can tell you a lot of things about it. And thank you for that wonderful introduction. Thank you for being here and having me. And thanks to all our audience. It's very nice that people have turned up. This is the first ever live stream of Young Scientist. And I am a learning facilitator at this organization. To those of you guys who are not familiar with Young Scientist, I would like to say a couple of lines about it. We are an educational startup, and we started about 5 years ago. And we have been doing science workshops, conducting science clubs, mainly to make learning fun, especially science for children. And we've come a long way. And since coronavirus started, we had we were unable to do face-to-face workshops and events. So we did a bunch of online workshops. And we did a series of workshops this month called the YS Space Missions. We did 4 of those, starting with the dawn of the space age, doing a case study on Apollo 11. And the next week we did a case study on Apollo 13, which was a disaster. And some like to call it the finest hour of NASA, or even a successful failure. It's a wonderful story of what happened to those astronauts who faced an explosion on their way to the moon and had to rescue themselves. In the last 2 weeks, we shifted our focus to the planet Mars, starting with the robotic missions that were initially sent, and ending with the possibility of human missions, and in the distant future, whether humans could live in Mars. There was a lot of interest in these sessions. A lot of questions were raised by the participants. Due to time constraint, we couldn't answer all of those questions, which is why we are here having this conversation, Atreya. And thank you for so kindly calling me a special guest. But I see you as a special host because you're one of our students. Isn't that right?
Yeah, that is right. I've been attending your sessions for 2 years. The sessions are very informative.
Thank you. Thank you for being very kind. So it looks like we have a bunch of questions to tackle tonight. Shall we begin?
Yeah. Okay. So the first question, which was raised by Shahida, what gases will they use to launch the rocket?
All right. This is from the first workshop that we did, the dawn of the space age. We spoke about the beginning of rocket science, starting from fictional ideas to science fiction, the early rockets. We even spoke about the Chinese rockets. Do you know what fuel they used in China?
No, I don't.
2,000 years ago.
No, I have no idea what they used.
China, well, the Kingdom of China at the time was very scientifically advanced when we compared with other places. They discovered many things, many inventions, including the gunpowder, which interestingly they did not use for destructive purposes, but they used it for um, making fireworks, including the kind of rockets which we use now in our festivals like Deepavali. Isn't that fascinating?
Yep, that sure is fascinating.
I have a question for you. Uh, what do you think they used as the body of the rockets?
As far as what I know, it's probably aluminum alloys.
I'm still talking about the ancient Chinese.
Okay, then I have no clue. I'm
Well,
absolutely clueless.
it's bamboo. It's very common there, and it's a hollow plant. Oh, excuse me. It's not a plant. It's a grass. Um, so there it is. That's um, that's the earliest rockets which used solid fuels. But what Shahida here is asking is about the more recent modern rockets. And nowadays we use liquid hydrogen and liquid oxygen. Hydrogen is an amazing fuel, and oxygen is the best oxidizer. In fact, those two make an explosive mix. Atreya, are you familiar with the Hindenburg?
I've heard his name before. He has a theory named after him, right? Heisenberg uncertainty principle.
Oh, forgive me. I'm not referring to Heisenberg.
Okay.
The Hindenburg. It was
No,
it was an airship.
no, I didn't. I don't.
Yeah. So before the Wright brothers made the powered flight, we had big balloons that were filled with hydrogen gas, and then
Yeah.
they floated through the air. They were airships. And the Hindenburg is famous for having hydrogen as its gas in the balloon, and unfortunately facing an explosion because hydrogen is very, very combustible. It explodes when given the right conditions. So yeah, we use the same hydrogen in modern rockets too. But since we need a lot of hydrogen, we compress it, we cool it in a concentrated form, also known as the liquid hydrogen. And then we have oxygen as well, which is compressed and condensed in a liquid form. And these two cryogenic materials form the fuels which power our rockets, the modern rockets.
Okay. Now, the next question, which is raised by Surya Vagini, is where do astronauts sit in the rocket?
Isn't that an interesting question? Rocket is a big cylinder. Where do the astronauts actually sit? Do you have a guess?
In the command module?
Command module. Oh, you have done your reading, Atreya. Then I must ask you, where do you think the command module is situated?
I don't know.
It should be the most important part of the rocket, and it's in fact it's at the very top. And so here we can see a picture of the interior of the command module of Apollo 11 spacecraft, which took the first humans to the moon. It's called the command module because the astronauts can issue commands, and control the spacecraft from here. They can communicate with the ground, and it's one of the most sophisticated control rooms you can ever find. But it's not very comfortable, as you can see. It's meant to be sturdy, to conserve space, and to provide ease of access to all the different controls. It looks as if every square inch is covered with switches and dials and gauges. Don't you think it would be quite confusing for the astronauts who sit there?
Probably not. Probably.
I think you're right, because they go through extensive training before they become.
Astronauts.
That's right. You see that we can see there are belts, like safety belts. They are strapped in quite tightly, since they are subject to a heavy acceleration and forces. And if we move on to the next picture, we can see the Saturn V rocket, which took the astronauts to the moon. Most of the rocket is just the engine and the fuel required to overcome the gravity. The Apollo spacecraft is at the very top, at the nose of the rocket. Move on to the next slide. We can take a closer look at the Apollo 11 spacecraft. Then we see the command module, which is known as Columbia. It's at the very top. It's like a cone, which houses the astronauts there. Behind the command module, you'll find the service module, which contains the supplies, all the scientific gear, equipment, food, oxygen. Yeah, that's the supplies over there.
Okay. Moving on to the next question, which is given by Daksh Bhatnagar, is this the real photograph from space, Earthrise?
Yeah, he's referring to the photograph known as Earthrise. Atreya, are you familiar with this photograph?
No, I haven't seen the photograph before.
Interesting. One of the nature photographers claimed that this is the most influential photograph ever taken. Let's put that up in the screen very soon. It was actually taken by an astronaut named William Anders in 1968. He was part of the Apollo 8 mission, which naturally came before the Apollo 11 mission. They did not land on the moon. They went around the moon, did an orbit, and they returned to the Earth. This particular photograph is influential because until then, every human had seen the sun rise, the moon rise, the sun set, and the moon set, almost every day of their lives. Well, except maybe the people with vision impairment. We had even seen the photograph of the Earth from space. Yuri Gagarin was the first astronaut around who went to the space. Lots of photographs were taken of the Earth from space, but this particular photograph is quite significant because it shows the Earth rising from the horizon of the moon. You can see here in the bottom left of the photograph the edge of the moon and the deep space, and then the Earth, just like a moon rising from the horizon. It's a very endearing photograph to us. The other planets, the moon, we take it for granted. It's always been there. It's just something on the sky. And our whole universe, our whole reality happens to be our Earth. And now we see as a very small planet rising over the horizon. Do you feel the beauty and the significance of this photograph?
Yeah, it looks amazing.
Don't we feel vulnerable? I mean, the Earth, our planet, our home, it's just there floating in space. It's kind of scary too sometimes.
Yeah, you look pretty puny.
Yes, it is. In cosmic scales, it's a speck of dust.
Okay, so now moving on to the next question,
Uh-huh.
which is given by Vishnu, is how is the flag flying on the moon?
Okay, so this is a very common question. A lot of people have this concern because see, the picture in question is this, which is provided on the screen now. When Armstrong, he planted the flag, the US flag on the moon surface, and this famous photograph was taken. People wondered, why does it look as if the flag is waving, fluttering? Because the moon has no atmosphere, there's no wind, and also because of gravity, that flag has to fall down, right? Flags only lift up when there is a wind. So this image is a cause for controversy. But with most controversies, it's also based on ignorance and a lack of attention to detail. Atreya, I have a question.
Yeah,
Can you see what's going on here? Why is the flag not falling down?
it's because there's no gravity in space.
There is gravity in space. I mean, the moon has a gravity, otherwise Armstrong here would be floating away. There is a weak gravity because of the moon.
It's held in place with crossbar.
That's right. In fact, I've even drawn a diagram here on the photograph with white lines. If we look closely, there is a pole which is, impaled into the ground on the moon. And across the pole, we have a crossbar, another pole, a stick extending. And from that pole, the flag is hanging. So it gives the impression that the flag is, waving. Also, it looks crumpled because that's exactly what happened. Nobody ironed the flag. It was, packed tightly in a tube, and when they unfolded it, it had wrinkles, just like how our clothes would have wrinkles when you crumple it into a ball and then unfold it. And yeah, maybe by now these, because of moon's gravity, the crumples would have smoothened out. So yeah, that's the story. The controversial picture is easily dismissed by looking closely at the photograph. Says something about human nature.
Okay, moving on to the next question, which is given by Pradyun.
All right.
Which is, how long do they stay on the moon?
How long? Do you have a guess?
A few months, maybe.
Pardon, a few what?
A few months?
Oh, we are talking about the Apollo 11 astronauts.
Oh, I have no clue.
Yeah, specifically Neil Armstrong and Buzz Aldrin, because those two are the only ones who went to the moon surface. To be exact, they spent 21 hours, 36 minutes, and 21 seconds. That is the amount of time the Eagle lander spent on the moon as soon as it touched down and just before it took off from the surface. But Armstrong himself, he walked around the moon for 2 hours and 12 minutes. NASA called it the EVA, extravehicular activity. The rest of the time they spent inside the Eagle lander, doing scientific measurements and um, preparing for the takeoff, because they were in a very hostile environment. I don't think any place on the Earth matches the same level of danger these humans face. It's complete vacuum out there. Atreya, did you know that the temperature difference between direct sunlight and shade on the moon could be as high as 300 to 400 degrees Celsius?
This is the first time I'm hearing about it.
Yeah, that's incredible. That means you go stand on the moon, you face the sun, right? Then the front of your body is heated up to about 250 degrees Celsius, and the back of your body is freezing cold. It's over negative 100 degrees Celsius. It's colder than dry ice. So you're being frozen on one side and burnt to the crisp on the other. Extremely harsh environment. So yeah, they really didn't have any time to dilly-dally, have fun. But in the 2 hours that they spent on the moon, they walked around. That was part of their test. They wanted to check the mobility, how well they can move. From what I read, the astronauts were quite fascinated with how the dust flew. They would kick on the moon surface, which is covered by a very fine layer of dust. And it was very interesting how the dust would spread. Unfortunately, they didn't take a video, but from their description, it's quite strange. You just have to wait for maybe 50, 60 years before they start moon vacationing. Hey, Atreya, would you be interested in taking a vacation to the moon?
Probably not.
Why are you skeptical?
It's circumstantial.
Oh, okay. Are you afraid of the dangers of space?
Probably.
I think everyone should be.
It's pretty hostile conditions up there.
Yeah,
You never know what can happen.
that's right. I mean, that's what we learned in the next workshop, right? In Apollo 13. Yeah, we'll talk about that later.
Okay. Moving on to the next question, which was given by Arnav. Has India sent any rockets to the moon which came out successful?
What do you think, buddy?
Yeah.
In fact, we have sent 2 missions to the moon, popularly known as the Chandrayaan 1 and 2. Since Arnav here is asking about the rocket, I think I should make a special mention about it. Chandrayaan 1 was launched by PSLV, which I'm sure everybody is familiar with. And Chandrayaan 2 was actually launched by GSLV. Do you know the difference between those two?
Is it engine difference? There's a different type of engine.
Oh, yes, absolutely. They also serve different purposes. Do you know what the difference in their purpose are?
No.
The PSLV stands for Polar Satellite Launch Vehicle, and GSLV stands for Geostationary Satellite Launch Vehicle. So those 2 rockets, they're launching 2 different types of satellites. And those 2 types of satellites, are called so because of the orbits they are put in. There's a polar orbit, which goes from North Pole to South Pole. Can you imagine that? Like
Yeah.
a longitude.
Yeah.
And geostationary is like a communication satellite. It's very far away, about 34,000 kilometers from Earth's surface, and it's stationary over a particular location. That way, it can receive signals and transmit it back.
Okay.
Okay.
Now, moving on to the next question, again by Daksh Bhatnagar, is were the Saturn V rocket parts reused?
Ah, this is a very good question. Something that a lot of people don't realize. Most of the rockets, most of them, 99.99% of the rockets are completely expendable. Okay? It's like a one-time use. These PSLV, GSLV, um, Saturn V, these are titles given to a model of a rocket. You know how we have um, like models of cars or refrigerators. The specifications are the same. You make multiple copies of those. Uh, Likewise, we have a very expensive vehicle. Saturn V actually burned on its way back through the Earth's atmosphere. So its only job is to push the payload. You know, Atreya, push the payload.
Yep.
Yeah, do you get the reference?
Yeah, I do get the reference.
Maybe some of our gamer friends in the audience would get the reference too. So yeah, that's their job. These rockets, they push the payload against gravity, um, and once they finish that job, they simply fall down after putting the satellite or the spacecraft in orbit. And when they fall down, they act like meteorites, and they free fall through the atmosphere, generating a lot of heat due to friction, and they burn up. Yeah, you only get ashes. So there's really nothing to recover.
Yes.
There's another popular question too, and what they ask is, where do these parts go? Where do they fall? Where do you think they fall?
In the ocean.
That's right. That's the safest target, right? It's very difficult to miss. 70% of the Earth is covered by ocean, so aim for that, and there's no risk of any human getting hurt, unless there's some poor chap in a boat. Okay. All right. Shall we move on?
Yep. Moving on to the next question, which is given by Anil Vinya.
Uh-huh.
How does this pen work?
Yeah, she is referring to the.
Space pen.
That's right, made by Fisher. Um, have you ever seen one of these pens?
One of my friends has it.
Yeah, they are quite popular as a gift, or as a souvenir. A lot of people who go to any of the NASA space centers, they buy it. Or you can even buy some online. They're not cheap. They're about $20 to $40 depending on the model you buy. They're quite special because, as the name suggests, they can be used in space, in zero gravity. Um, and what makes this possible? Because you can't use a fountain pen or a ballpoint pen, because all of those pens need gravity to work. And we can sympathize with this problem by attempting to write upside down. Have you ever tried to do that?
It doesn't work.
Yeah, it's difficult. It might, even with ball pens, they might work for some time, and then eventually it would stop, it would thin, the trickle of ink would thin out and then stop. And in fact, it's a bad idea to do it because it will cause a backflow of the ink in the refill, right? And then it will,
Face.
yeah, and there could be it could cause a gap between the ball roller and the ink, rendering the pen useless. Space pen overcomes this by using pressurized gas. They use nitrogen. There's such high pressure, it's liquefied, and it's also a very special ink. It's highly viscous, and this type of material is known as thixotropic, and it only flows when it's subject to high pressure, which is provided by this container of pressurized nitrogen. And I must mention the tip. It's like a ball pen. It's a ball, but it's made up of a special substance known as tungsten carbide, one of the strongest materials we know.
Okay.
Yeah.
Now moving on to the next question, which is given by Ananya.
Uh-huh.
Who is going to give the money to make the spaceships?
Yeah, this was a good question. This was a natural follow-up to the slides which I showed about the spending, the amount of the budget of the NASA and how much it cost to build the Saturn V rocket for the entire Apollo program. It's a huge number. It's a lot of money. Like it's almost $1 trillion. If you look at the entire spending of the globe, it's mind-boggling. Yeah? But would you like to guess who funds this exploration?
The government.
Yes, absolutely. Again, I must say, mostly, almost 99.99%. Just like I said, with the expendability of rockets, because these two are related. Most of these space agencies are government organizations, so they are funded by the budget, right? Part of the budget. And where does the government get money? From the people, through taxes. So we fund, it's like the biggest crowdfunding campaign. Right? All the people pay taxes, and the government uses a portion of that for funding these space missions. The number might be quite large, several billions, but if you look at the percentage, it's not quite alarming. It's about only, rarely it goes to 1 minute. Sorry, excuse me, 1% of your total budget. Another thing, which ties into the expendable rockets, is nowadays, recently, the past decade, a lot of private space agencies have started gaining significance. Can you think of any one?
SpaceX.
Yeah, the most famous one, right?
Yep.
Why do we know SpaceX?
Because of Elon Musk.
There we go. Yeah, I guess we could call him. What do we call him, Matre? Yeah.
Ant-Man.
The Iron Man. Okay. I call him the hipster of entrepreneurs.
Sure.
Yeah, it's quite an interesting character. Did you see one of his recent tweets about Mars, terraforming Mars, where he said that we have to nuke the Mars?
No, I will have to read the tweet.
Yeah, it's very interesting. It's quite fun too. But yeah, SpaceX and several other private companies are entering the space exploration. It's becoming an industry. We know that Virgin, another company, has an interest in space tourism. And one of the things SpaceX is known for is the development of reusable rockets. So that's going to cut costs by a lot, because like the space shuttle, which takes astronauts to space and comes back and can be reused. Elon Musk is developing reusable rockets through SpaceX. So these rockets can go, put a satellite in orbit, and come back to Earth to be reused again after refueling, which is great. So while a lot of the money is funded by the government, there are also private companies which are funded by individuals or investors. So the future can be quite interesting as to how this develops. Yeah, shall we move on to the next question?
Okay, moving on to the next question, which is given again by Anirvinya, is how do astronauts drink water and eat food with no gravity?
Yeah. How do they drink water and eat food with no gravity?
They're, they're dehydrated, right?
Hmm.
Most of the foods are dehydrated.
Oh, oh, I see what you mean. Yeah. See, there's been a lot of development in space food too. Initially, it was mostly dry food, like you pointed out, processed foods. Um, I can show a picture here on the screen. Um, biscuits, candies, protein bars, and the like. Um, but as technology improved, as we learned more about our human body, we were able to get more adventurous too. I mean, astronauts in the ISS, they are able to make pizzas and tacos. They can eat fresh fruits. Yeah, they don't have any pan because food would just float through space. They have special equipment for preparing them. So yeah, food is becoming more and more normal. Space food is becoming more and more normal. Um, I think Anivinia's question is more about how does the food get inside our body? I mean, there's no gravity for it to push down. But a little known fact is that we don't need gravity for food to go down. Our food pipe, that's the tube that goes from our mouth to our stomach, it's almost like a snake in that how a snake swallows food and it moves through its body. Our food pipe, esophagus, can force the food to move through the tube. This is known as the peristaltic movement. Uh, this is quite strong, so strong that it can work against gravity. You can stand upside down and eat food, or even drink water. Although I wouldn't recommend this. You might, end up coughing. Food might enter the wrong hole. But what you can safely experiment with is lie down on your side, and drink a little bit of water, or eat a piece of snack. And you'll find that you can ingest it, you can swallow it without much trouble. And hey, we all know that the reverse peristaltic movement can work against gravity, don't we? Do you know what I'm referring to?
Nope.
Reverse peristaltic movement.
Yeah, vomiting.
That's true. I mean, we don't have to stand upside down for it food to come out. I mean, it gets forced out of our body.
We just have to eat too much at the same time.
Yeah, yes, that's one of the reasons why we throw up. Yeah, so the muscles, they can push food against gravity in either direction. That's not a problem. So swallowing is not a problem. Food is also not a problem. It's becoming more and more like comfort food for the astronauts. Shall we move on to the next one?
Yep. Okay, moving on to the next question, which is given by Ananya. After going to space, will the spaceship split into parts? Right? Why do it split like that?
Do you understand what Ananya is getting at here?
Yep.
Yeah. I believe she is referring to the different
The
stages.
stages of separation
Yes.
of the rocket.
Do you have an idea, Treya, why rockets have um, this multiple stages?
It's because of maybe weight, fuel. Once you use the fuel for one stage, You remove that stage so that you also decrease weight and you gain momentum.
That's an interesting um, idea. Yeah, that's very nice. That's definitely an advantage. Let me pull up that image of the Saturn V rocket again. Um, you see, the amount of thrust, the push that the rocket requires at each stage as it climbs through the atmosphere, it changes. Just like how we require a lot of force to get something to start moving. Have you ever tried to push a car?
It doesn't work.
No?
It
Damn.
doesn't work.
Do you ride a bicycle?
Yeah.
Now, I'm sure you can relate to this. When you start riding the bicycle, it's difficult. Once you get going, it becomes easier, doesn't it?
Yep.
That's mainly because of the inertia that we gain. So the initial thrust, the initial stage, the first stage, requires the most powerful engine, and that's usually the biggest engine, the biggest stage. And once we gain momentum, we don't need that anymore. So we can uh, detach it and then get rid of it. And like you pointed out, it also reduces the mass of the remaining rocket, so it becomes even easier to push it. You move a certain height, dispose of that other stage two, the other engine, turn on the next engine. This is a great design, a great solution, but there's one a problem with this. What do you think that is?
I don't know.
It introduces an added complexity to the design, right? You have two engines that are in standby, which needs to start, and one of the most popular problems around the world is, what is it?
Which is?
Starting trouble.
Oh, starting trouble.
Yeah, I mean, with engines everywhere, I'm sure everybody has faced this or witnessed it at one point or another. Sometimes the engine just won't start. And when you're launching a rocket, when the rocket is in mid-flight, you cannot have a starting problem. That would be disastrous. Wouldn't you agree?
Yep.
Yeah. It's always better to have a simple design. But the multi-stage rockets are quite fine. We have tested them very rigorously, and they are some of the best rockets we currently have. All
Okay.
right. Yeah.
Moving on to the next question, which is given by Pradyuman. Which rocket has the best chance of a manned mission to Mars?
Okay. So we need to make one thing clear before we try to answer this question. When any of those astronauts went to the moon, right? It's the rocket never reaches the final destination. See, the rocket's job. Do you remember what I said?
Yes, to get it out of the Earth's orbit.
Correct. That's it. The rocket's only job is to overcome Earth's gravity and put the satellite or the spacecraft into outer space in orbit. So it's from the Earth's surface to the outer layers of Earth's atmosphere. That's the only purpose the rocket serves. Once it's done, it falls down, or if it's a SpaceX rocket, it can find its way to the base. After that, what happens is either the satellite stays in orbit, or the spacecraft, like the Apollo 11 spacecraft, it's put into a trajectory, a path to the final destination, which could be the moon or the Mars or whatever. So it's a spacecraft that travels, not the rocket. So to answer Pradyum's question, if you rephrase it, which spacecraft has the best chance for a manned mission to Mars? As of now, none. There's no spacecraft that has been built, but we have designed or made plans for future spacecrafts for this very purpose. So here on the screen, I've shown the picture of one of the prototypes of an interplanetary spacecraft. Do you want to guess who made this design? Yeah. Did you recognize this photograph?
I've seen it somewhere before.
Yeah, and in fact, this spacecraft is designed to take up to 100 passengers to the Mars. Or at least that's the concept of it. What do you think? Do you think it would get there?
How long does it take to get to Mars in the first place?
That's a very good question. So, you see, the first thing we need to recognize is that you don't just pack your bags and go to the Mars. There's a very small window of opportunity for this to happen. It happens only once every 2 years. You see, Mars takes about twice as long to go around the Sun. So once every 2 years, the Earth and the Mars are at their closest positions.
Yeah.
So that's the time when you have to launch your rocket and you send your spacecraft on its way to the Mars. And you take advantage of the Earth's orbital speed and the closeness between the two planets. And then you use that to move to Mars. And the best estimate we have right now from the satellites we have sent to Mars is that it takes about 11 months to get there.
Okay.
And
that's a year.
Yeah, it's almost a year. And that's very long. It's a long time to spend in zero gravity, to space. But most astronauts do not spend that much time in the space station. They rotate more frequently. They only spend a few months.
Okay. Moving on to the next question, which is given by Nisha, is will we sweat inside the spacesuit when we wear it?
Oh, that's a very pragmatic question, isn't it? Will we sweat inside a spacesuit? What do you think?
No comments.
Okay. Now, one of the most prominent features of the spacesuit is, what would you say it is?
The thing in the back.
Correct. The thing in the back. Right? What the hell is inside that? There should be something that's.
It connects the oxygen and maintains pressure, right?
Yeah. So it has a name. That's a term. It's called as the life support system.
Support system.
Yeah, it provides the air that the astronaut breathes. It also has a filter that removes the carbon dioxide which the astronaut breathes out, which is a poisonous gas. It cannot exceed a certain concentration. Otherwise, he will feel adverse effects. It also includes how to put it, a mini air conditioner or a heat regulation system. So the temperature that the astronaut feels inside is regulated strictly. Only a few minutes ago, I told you the extreme difference in temperature between the sunlight and in the shade.
Yeah.
And we can't have the astronaut, the human who's inside the spacesuit, feel that difference in temperature. So they are highly insulated, and even when the insulation is not sufficient, there is a fluid that keeps that is kept rotated, that cycles through the suit, and there are heat exchangers, coolants. So an astronaut is quite comfortable. In fact, in the words of Armstrong, his spacesuit was quite cozy compact and almost cuddly. That's how he described it. Sounds comfortable, if you ask me. Yeah.
Okay, moving on to the next question, which is given by Dhruva, is
Uh-huh.
how do astronauts use the toilet in space?
Oh, the $1 million question. How do astronauts use, how do they answer the nature's call when they are beyond the effects of gravity? Well, it's obvious that I can't show you how it's done, but we can talk about it. See, first we need to recognize the problem. On Earth, gravity makes it very simple. Whatever we eject from our body, right, it falls down. But in space, it doesn't. So whether we, spit, you know, whether it's we pour some water out of a bottle, it doesn't fall down. It just floats around, and we cannot have any human waste floating around inside the spacecraft. So the space toilet is a machine that's kind of attached to a vacuum cleaner. And what astronauts do is they strap themselves to the seat. So the space toilet is like a Western style toilet. They strap themselves tightly, okay? And then they do their business, and then they turn on a switch. And what happens is there's a vacuum cleaner which sucks the air and all the waste that was ejected. And then this waste is dried, and if there's any moisture that can be reclaimed, it is done. Because in space, you simply cannot waste resources. Yeah. And in addition to, the business of the toilet, astronauts also have to keep themselves clean, right? They do brush their teeth, and they shampoo their hair. But what they use is like a special type of shampoo and toothpaste which does not require water, because you can't just have water floating around, because it can cause short circuits if it finds its way to a circuit. It's very, very risky. And for cleaning their bodies, astronauts use like alcohol to rub themselves clean. Alcohol kills bacteria. And they also use wet towels which are soaked in soap. So I think they call it a French bath. That's how they keep their bodies clean. There's no space shower, unfortunately. We don't have that kind of luxury now.
Okay.
All right.
Moving on to the next question, which is given by Kritik, is why do people place flags on the moon?
Why do people place flags? We can ask the same question of any expedition that has been done. Right? People have gone to many remote places on the planet, and they kind of claim the place they go to by placing a flag. Usually, it's the flag of the country that funds that expedition. Explorers a few centuries ago, like Vasco da Gama or Columbus, they were funded by the kings and the queens, because the kingdoms wanted to expand. They wanted new territory to go and claim. That's the origin of this practice. So you go to an unknown place somewhere no humans have gone, or some place where any man from that civilization has gone. And then they go and then they claim that land by saying this belongs to this nation now, this country. So they plant the flag. It's a symbolic gesture. It's kind of outdated now because the moon does not belong to any country. It's like Antarctica. It's neutral grounds. It's for scientific purposes alone. It was also the first explorers who went to the South Pole and the North Pole, they planted the flags of their respective countries. Although it means nothing than just a gesture or a symbol that people from those countries went there. Yes, I think it's only a tradition that we are still following.
Okay. Moving on to the next question, which is given by Likita.
Mm-hmm.
What kind of music do planets sing?
That's a very interesting question. I won't assume, I won't claim to pretend that I won't claim to understand this question. What kind of music do planets sing? When I went back and read this question in the chat history, it got me thinking about, well, one, what the child could have meant, and also when I dug about it, I found some interesting notions. They're not in the mainstream science, so I will not go in deep about it. But Atreya, are you familiar with the concept of resonance?
Yeah.
So you know about tuning forks, right?
Yep.
What do you know about resonance? How would you explain it to someone?
Movement of sound waves that produce vibration.
Yes. It actually gets a little more complex than that. So all objects, they vibrate at a certain frequency. Tuning forks are the most common example. You create them, you design them so that they vibrate at a desired frequency. But any object is a vibrating object. It could be a table, it could be a pen. Our own human body can vibrate at a particular frequency. This is known as the natural frequency of the object. And when the natural frequency of an object matches an external frequency, which could be vibrations caused by a tuning fork or vibrations of produced by a speaker, then when these two matches, the external frequency and the natural frequency, we have resonance. And planets, they're also objects, and therefore they have a natural frequency. So you can say that planets are singing, so to speak, in that natural frequency. And in fact, some musicians have taken, notes from these scientific studies, and they've kind of extrapolated those scientific results into recognizable sounds corresponding to each planet. Although planets vibrate at a very low frequency, which our human ears cannot hear. So they change, they move the musical note by several octaves so that it can be heard by humans. And it's quite interesting that there's music which have been composed based on this principle.
Okay, moving on to the next question, which is given by Daksh Bhatnagar, is why do people say that Apollo 11 was fake?
Well, before I try to answer that question, I have a question for you. Do you think Apollo 11 was faked?
No.
Why do you not think that? Why do you think it's genuine?
It looked real.
But that's not a sound scientific argument, is it? Appearance cannot be a proof. And what convinces
So we
you that
basically
it's...
have no proof. It could be faked, it couldn't, we don't know, do we?
That's how it would seem when we look at it from the outside, right? We only hear news, and we
We
only
assume it's real.
yeah, news can be fabricated. We shouldn't believe everything that somebody tells us.
Yeah.
Not even the newscaster, right?
Yeah.
There is a concept known as journalistic integrity, that uh, journalists they only report news that they believe or they're verified their facts and sources. In fact, that comes to the next thing, sources. Every piece of information has a source. When we need to assess information from where it comes from. If you look at all of these the controversies, the source of these conspiracies, it does not come from any respectable source. And by that I mean any established uh, institute or organization or an independent scientist who has published many papers that's peer reviewed or that is verified by other scientists. That's how science works. You do an experiment, you get your result, and you publish it in a paper, and then other scientists would read it, they would repeat that experiment, they'll verify it. When they verify, they'll publish another paper saying, hey, I did the same experiment, I changed this, I improved this, and I got the same result. Or they can say, no, I did not get the same result. There is a conflict here. There's a discrepancy of results. And then it will create more interest. More scientists will look at it. Oh, so they've done two different experiments about the same phenomenon, they're getting different results. So that's how the entire scientific enterprise works. It's a teamwork where each scientist is trying to cross-verify each other's results. So when this Apollo mission happened, these results, these data, they were not only a property of NASA, they were shared with the entire scientific community. All of them were using this data, they were verifying it, they were analyzing it. It wasn't done, within closed doors. The part of the program was secretive. It's in the technical details of the rocket, the blueprints. So that's something they don't want to release it to everybody. They wanted to protect that information, but the scientific data was shared. And if it was faked, as many of these, doubters tend to claim, then surely some of the scientists would have realized that and made it public. Thousands and thousands of scientists and engineers were involved in this project. So it's kind of outrageous for individuals to claim that it was fake. But the question here, if we look at it semantically, they ask, why do people say? It's almost like a question about the psychology. Why do we believe that the accomplishments of others is less than what it appears to be? I don't know. I think it's something of a bad psychological habit, a tendency that we have. Do you understand what I'm getting at?
Yep.
When someone does something good, maybe it's because of I don't know, envy or jealousy, that we try to bring them down. We see this tendency everywhere, and such tendencies get a lot of popularity when it's attached to big projects or big names. Controversies have always been popular, and news agencies love this. I mean, by news agencies, spurious news agencies like Pulp Fiction, tabloid news.
Okay.
Yeah.
Moving on to the next question, which is again by Daksh Bhatnagar, is it real? Is the real CM?
Can you guess what he's referring to by CM?
Yeah, Apollo 13 command module.
Yeah, that's right, the command module. So let me pull up the photograph he's referring to. This actually the command service module that suffered the explosion um, that happened during the space mission. See, Apollo 13's spacecraft suffered an explosion of one of its oxygen tanks midway to the moon, and they had no clue what happened because they couldn't go to that place. They couldn't go out and take a photograph. But when they were successfully, rescued themselves and came back to Earth, they disengaged the service module, the command service module, and that's when they were able to take a photograph. And here we can see the extensive damage that the module had suffered. One of the big panels had blown off, and it's an amazing story as to how these astronauts were able to survive. There were several constraints. There was a constraint of fuel. There was not enough fuel. There was not enough oxygen, or rather, there was not enough ways to remove the carbon dioxide that they were breathing. And yeah, this is a real photograph that the astronauts took just before they were re-entering the Earth's atmosphere and coming back home. Yeah.
Okay. Moving on to the next question, which is given by Sai Tanishka, is why do we not know who discovered Mars?
It's a fond question. I'm fond of this question because I was kind of playing with the participants at this time. It was like a trick question. I asked them who discovered Mars when we started the session on Mars. I was giving a brief description about Mars, and then I asked, okay guys, I have a pop quiz for you. Who discovered Mars? And I got some interesting answers. Can you imagine what they said?
No.
Okay, I'm asking you this question. Who do you think discovered Mars?
I'd probably say no comment.
You're very safe. Okay, how about this? Who do you think discovered the moon?
I don't know.
Come on, Athreya, give it a little bit of thought. Just think about it. Who discovered the moon? The moon.
Some ancient Chinese person.
Well, how do you discover something that is in plain sight? It's not a discovery. No one can claim to discover the moon because it's there for everybody to see, right? From prehistory humans, all they had to do was look up and say, oh, the moon. Hey, there's something there in the sky, in the night sky. It's kind of a trick question. With the moon, it's very obvious. The moon itself is obvious. You don't claim discovery for something that is obviously seen. And same goes with the Mars too. But the point I was trying to get at is Mars is a planet, and planets look differently in the night sky when compared to the stars. Do you know how?
It's a phenomenon in light.
Yeah. Stars, they twinkle, and planets, they don't. So Mars, even though it looks like a star in the sky, if you look closely, you will see that it's reddish and it does not twinkle like other stars. It stands out. So nobody discovered Mars, but I got answers like Galileo or Copernicus or Kepler. It was fascinating. And then I asked them who discovered moon, and then I think that's when they got the idea. It's not a genuine question, but a trick question. Yeah.
Okay, moving on to the next question, which is given by Dhruva, is has it erupted with reference to Mons Olympus?
Yeah, Mount Olympus. It's one of the tallest mountains in the solar system. Have you seen a photograph of it?
No.
Yeah, let me pull that up for everybody to look at. It is a volcano. It's found on the Mars. It's about 22 kilometers tall. Uh, in comparison, Mount Everest is only about 8,800 meters. So I would say about 2.5 times as tall as Mount Everest. And naturally, the kid's imagination goes to, wow, if this is the biggest volcano in the solar system, imagine the eruption of it. But unfortunately, Mount Olympus is a dead volcano. Mars is almost dead. By that I mean it has lost its internal heat. There's not much activity in the magma, the internal layers. So Mount Olympus is not going to erupt anytime soon or ever in the future. And the last time it probably erupted was maybe billions of years ago. We need to make a time machine to go back in time and see it. Wouldn't you like that?
Maybe.
Okay. All right. We can move on.
Moving on to the next question again by Daksh Bhatnagar is, how do robots land on Mars?
Yeah, how do robots land on Mars? That's a rather revealing question. Mars does have a greater gravity than Moon. In Moon, it's about 1/6 that of Earth's gravity. In Mars, it's about 1/3. So that's about twice as strong as Moon's gravity. One advantage is Moon has an atmosphere, so you can deploy parachutes, but the atmosphere of Moon is very, very thin, about 100 times thinner than the atmosphere of Earth. So parachutes are not as effective. So you need to use a combination of parachutes, balloons, and balloon cushions that wrap the lander, yes, where it can gently, with whatever force it falls, impacts the ground, it can bounce and not get damaged. Some landers also use reverse thrusters, small rockets that can slow it down where it can land nicely.
That's how Curiosity landed, right?
Yeah, that's it's known as a soft landing. And then what you find inside is like this case, this box, and that opens up, and then you have the robot inside. The rover rolls out. Did you know it takes about 11 minutes for a signal to come from Mars to the Earth?
No.
Yeah, that's the time delay. That's how far Mars is.
Okay. Now moving on to the next question, which is given by Zakaria, is, on which date did the Curiosity rover was sent to space?
What coincidence! You just made a mention about the Curiosity rover. This this boy must have a strong liking for history. It's very fascinating. I just mentioned Curiosity during the session, and then he asked me, on which date was Curiosity rover sent to space? Just to satisfy him, it was the 6th of August 2012. I remember that month, maybe that week. I was just about to start my master's in physics. I think about 2 weeks before I started it. I was preparing to leave for the university. I was saying my goodbyes. Yeah, it's almost 8 years ago, 2012. Hey, guess what, Atreya? You remember the fuss about 2012?
Which was,
About the Mayan calendar and
oh God.
thing. Yeah, imagine how many, a lot of people were making noise.
Okay.
They were calling, I think we call them alarmists. I think we also had something like that for 2020. Somebody messaged me about this, saying, will the world come to an end? I don't know. People have a liking for big disasters. The
Me
Armageddon.
included.
Really?
Yep.
Yeah. It's not.
Okay. Moving on to the next question, which is again by Daksh,
Uh-huh.
is if tensegrity robots have no wheels, how do they move?
Oh. Um, hey, are you familiar with tensegrity structures?
Nope. Haven't heard of them before.
Okay, these are really cool structures made up of rods, sticks tied together by strings. Okay, what makes them interesting is you crush them, right? You collapse them, and
Yep.
it will regain its shape. Or
Oh my God.
yeah, they're not under pressure. So the members are not under pressure. They're under tension, meaning they're being pulled. They're not being pushed. Let me show a picture of a tensegrity robot. So here we see that this robot is made up of 1, 2, 3, 4, 5, 6 rods, right? We call them as trusses. And then there are studies, research going on making robots based out of this structure because it's extremely stable. It's not a rigid structure, it's flexible. So if it falls into a pit or something crashes into it, it can reorient itself. Okay? Almost like a jellyfish, sort of, or an amoeba. Right? It doesn't have the same level of flexibility, but it's much more flexible than vehicles. One big difference, unlike a rover, it has no up or down. Right? Rover has a one particular orientation. It needs its wheels on the ground so that it can move. But tensegrity robot doesn't have wheels, so there's no right way. But yeah, I need to answer the question: how do they move without wheels? Now, these robots, they have these strings, right, connecting them. They can be the tension in those strings, they can be changed. The length of the strings can be altered. There are several motors which do this, and by changing the relative length of the connecting connecting members, the strings, you can make this entire structure move. It can make it roll. It's almost like an amoeba that's rolling. And the advantage is you don't need a smooth surface or a flat surface for this to traverse, for this to move. So that's why it's of high interest for a NASA, especially to build robots like this, which can be sent to Mars. Yeah, I think the future generations of Mars rovers would be tensegrity robots. Yeah.
Okay, moving on to the next question, which is again by Daksh,
Uh-huh.
is how did they take pictures of Venus?
It's too hot. Extremely hot. He's right. Venus is extremely hot, over 400 degrees Celsius. And you know what else is terrible about Venus?
Its atmosphere is made of sulfur, sulfuric acid
Uh-huh.
clouds.
Yeah. And it's extremely thick, right?
Yeah, the atmosphere is very dense.
Yes, and that increases the pressure. It's almost 100 times the pressure as what we feel on the Earth. That's like traveling almost 1 kilometer underwater. Because people didn't know, you can't do it without being inside a submarine. Because at that pressure, you will get crushed. The pressure would break your bones, crush your lungs. Air would be pushed out of your lungs. It's very dangerous. And in fact, it's not only dangerous for the human body, it's also dangerous for spacecrafts and landers that go to Venus. The first ever photograph we took of Venus comes from Venera 13. And I have that here on the screen for everybody to see. Can you guess how long Venera 13 survived?
2 minutes.
Oh, that was the amount of time the Venera 1 survived. It was sent by the Soviet Russia. And it only lasted for a few minutes. But Venera 13, it lasted for 57 minutes and was able to take photographs, the first ever photographs of the Venus surface. And then eventually it failed under the heavy pressure and temperature. And who knows, it might have even suffered, you know what kind of rain we get on Venus, don't you?
Yeah, acid rains.
Yeah, concentrated sulfuric acid. And the metals just dissolve under such conditions. But yeah, it is a real photograph. It was taken by a very sturdy spacecraft known as Venera 13. Okay.
Okay, moving on to the next question, given by Farhan.
Yeah.
Is how is there oxygen generated in space shuttles such as the ISS?
Good question. Well, one, they do have a reservoir of essential supplies like oxygen, power for electricity, water, but they also are very, very efficient. They reclaim the waste, they reuse all resources, because it's not easy sending materials from the Earth's surface to ISS. And one of the ways they generate oxygen is by using a fuel cell. Are you familiar with this?
No.
A fuel cell is a type of battery in which you combine hydrogen and oxygen, just like how you combine it in a rocket engine, but you do it in a very controlled way. It's very slow. It's not an explosion. It's a small chemical reaction that's highly controlled. And then when this produces heat, and that's converted into electricity. But do you know what the end result is when hydrogen and oxygen combine chemically? Atreya, are you there?
Yeah, I'm right here.
Yeah. So I was asking, do you know what would happen when hydrogen and oxygen combine?
Hydrogen and oxygen become water.
That is correct. So that's one way astronauts they make water by combining hydrogen and oxygen and produce electricity. The reverse is also possible. You can pass electricity to water, and you will get back hydrogen and oxygen. That's what astronauts do.
Okay, moving on to the next question, which is again by Farhan. Is there any evidence of life on Mars? If so, is there a chance humans also thrived in Mars and later got extinct?
Okay. Well, what do you think?
I don't think so.
No, you're right. We have not found any evidence for any form of life on Mars. But what we have found is sufficient evidence for the existence of for water on Mars. Although it's not liquid, it's
That could
frozen.
have been like an illusion that was formed due to camera lens. Like an optical illusion.
Yeah.
Like before, like NASA sent the rovers to Mars, there
Yeah.
have been a few. There have been a few scientists who had claimed that they have found streams of liquid water, but
Yes.
then it only turned out to be scratches on the lenses.
Ah, yes, yes, yes.
It could have been the same thing.
Yeah. So the previously outdated evidence for water was, unfortunately, was a technical problem, a smear on a scratch on the lens, photographic lens. But um, later we have sent more advanced satellites with more advanced probes. So they do seismic studies, they use radar, they use ultrasonic waves to find out what's underneath the surface of the Mars, and they have found unequivocal evidence that there is frozen water. They even did chemical analysis of it. What's interesting is we see geological evidence for the existence of flowing water in the Mars of the past. And by past, I mean several billion years ago, probably when Mount Olympus was still active. Uh, Water did flow on Mars once, very long ago, but most of that water, along with most of its atmosphere, is lost now because of its weak gravity. So, yeah, no life on Mars, no evidence for life. There's no evidence for humans or humanoid life forms ever having lived on Mars. It's just wishful thinking. Yeah.
Okay. Moving on to the next question, which is again by Farhan,
Uh huh.
is there is an opposite of nuclear fusion where you remove a cell from a bigger cell. It is said to provide a ton of energy, but we have no container powerful enough to do this.
Ah, yeah. So we need to clarify this for our viewers. um, the opposite of nuclear fusion will be nuclear fission. That's where you remove uh, not a, we don't call it a cell. We are removing we are breaking down nuclei, the nucleus of an atom. We start with a heavy nucleus like that of uranium or plutonium, and then we break it down by throwing neutrons at it. When this happens, it releases energy. This is actually a viable source of energy. We have nuclear reactors, and they use nuclear fission as a source to produce heat and electricity. The opposite of nuclear fission is nuclear fusion, where you combine small nuclei and then you generate energy and electricity. This is what is still not practical. Okay, we don't have a container or containment technique to make this controlled. You can only do this in an uncontrolled way. Atreya, do you know what you get when you have an uncontrolled nuclear fusion reaction?
Yep, you get a nuclear disaster.
Yes, also known as a hydrogen bomb. So, yeah. I think the next question will be the last one for the evening, isn't it?
Yep.
What is it?
It's again by Farhan.
Uh huh.
Is it possible to take the DNA of this cellular creature and mix it with other DNAs to construct and breed an animal which needs no oxygen to live?
Very nice. So, the context for this question is that in the last session of the space mission series, we were talking about terraforming Mars. And one of the problems, the biggest problems we realized was Mars has a high concentration of CO2 and not enough oxygen. Uh, we saw that plants, although they mostly need CO2, they also need oxygen to survive. Most animals, they require oxygen to survive. And then I showed them the example of cyanobacteria. Are you familiar with that?
Yeah.
Yeah, it's a very interesting class of uh, cellular organism. It converts carbon dioxide to oxygen. And in fact, in the early Earth, that's about 4 billion years ago, uh, uh, the atmosphere was much like Mars, mostly made up of carbon dioxide. So the first life forms were the ancestors of cyanobacteria, and when they grew and then they thrived, they converted the CO2 into oxygen, leading to the evolution of aerobic organisms like plants and animals which use oxygen. Even there's certain algae that convert carbon dioxide to oxygen. And his question is, could we use this? Can we translate this ability to another organism? And Farhan is talking about a technique known as CRISPR. It's something that's almost straight out of science fiction. It's a rather new piece of technology. While genetic engineering and biotechnology developed, humans gained a very almost surgical control over our DNA. They were able to isolate genes and then recombine it with the DNA of other organisms. So in this way, they could create almost like reconfigured DNA, a DNA which has pieces from a rabbit and from a lion. Now, in real life, you cannot cross those species. You can only cross similar organisms. You can cross maybe a lion with a tiger or a horse with a donkey. That's when you get a mule. But with CRISPR technology, you can take pieces of DNA of one organism and then you can insert it to another. Farhan's question is very thought-provoking. It asks, could we take that ability to convert CO2 into oxygen from cyanobacteria and then insert it to other organisms so that we could create life forms that can live on Mars? It's quite possible, but I must say it's going to be very, very difficult because most organisms are complex. We are made up of several types of cells, and you will have to change not just one part of you, one DNA. It's a very complex system, and without getting into the details, I can say it is possible, but in the distant future, maybe at least a few thousand years from now, we don't have that level of control over the design of an organism yet. It's a very good question. Yeah. All right. So with that, we come to the end of the Q&A segment, and I believe Atreya, you have to get out of here. Is that right?
Not exactly get out of here, but yes.
All right then. So I still have a few more things to say and wrap up this live stream. But before I let you go,
Yep.
thanks a lot for being here, for joining me in addressing these questions. How do you feel about the questions raised by these kids? They're
They're
about
pretty
your
good.
age, most of them.
They're pretty good.
Yeah, what would you say is your favorite question?
Oh, my favorite question.
Uh-huh.
I'm telling you that.
Which one?
It is. Yes, were the Saturn V rockets parts reused? That's a question which even I had. Are
Oh,
any rocket parts reused? Depending on any rocket, it's any rocket for a matter of fact.
uh-huh. Okay. All right then. That's a very good question. Uh, Thank you, Atreya, for being here tonight with us. Um,
Thank you for giving me the opportunity to be here.
You're welcome, buddy. I hope to see you in the astrophysics course. Isn't that right?
Yep.
So you have enrolled for ASP
Ref-
2301. Are you
Yes.
excited?
Yes, I am excited.
Yes. Little known fact, I studied physics in the university. I started in 2012, and my specialization was in astrophysics. And
Okay, then this is gonna be fun.
yeah, and it's going to be quite demanding. I'm not going to be easy on you fellas.
Oh, no, no.
Yeah, it's going to be for 8 sessions, 16 hours,
Yeah.
and it will be 2 hour sessions, and we'll be doing this online.
Yeah.
And since by now we have done a lot of sessions, and our children have also become quite comfortable, and there will be it will be a very structured course. It will be similar to how some of my college courses were designed. I'll give you some reading tasks uh, before a session, and then we'll have a lecture, sort of. And then
Okay.
the last 30 minutes we'll have an open discussion, or how universities call it as the recitation segment. And that's when we debate, or in universities we solve problems. And we'll try to do that as much as possible during this course.
Okay.
Are you afraid of mathematics?
I like mathematics.
Very good, because we are going to use mathematics in this course.
Not a problem.
Yeah, but we won't get too crazy.
Okay.
So in the previous sessions and workshops and courses that we did, I think you attended the 12-week course too, right?
Yes.
Okay. So we did not get much into the mathematics. I've
Yeah.
shown you the equations.
Yeah.
So in this course, we'll go a step further. We'll try to solve simple problems.
Sure.
Just the mathematics you learn at school.
Okay.
We'll apply it to some astrophysical objects.
Okay.
Yeah. All right. So I guess I'll see you on June 5th then. Yeah?
Yeah. See you too.
All right, Atreya. You have a good night.
Thank you. Good night to all the audience and you too.
Thanks, buddy. Bye.
Bye.
All right, fellas. That's a thank you from Young-Scientist. This is the voice of Satish. I'm one of the learning facilitators at Young-Scientist, which you guys know as your favorite destination for science through visual learning methods. You know, we make learning fun. Thanks a lot for being here with us, spending almost an hour and 40 minutes. As I was speaking with Atreya, we will be starting the astrophysics course on June 5th, and there's a lot of other workshops slated for the next month. We don't really have a theme planned like we had in May. But the next two workshops on Wednesdays are going to be on nuclear fission and fusion. And Shilpa, my colleague, will all continue to make and conduct sessions for younger kids about other topics, a variety of fun topics. You guys can join us. Okay. In these sessions. The link to our website and our social media is available in the description. Please take a look. Our website will guide you about enrolling for these courses and workshops and whatnot. You can follow us on Facebook and Instagram for occasional posts and getting notified. And we may continue to do more live streams like this. So if you want to be notified of these things, you know what to do. Hit subscribe, hit the like button, and then hit the notification bell. And I'll see you guys another time. So good night from Satish, and good night from the entire Young Scientist team. Bye, guys.